determine the magnitude of the minimum horizontal force required to maintain a box of width 20 Newton when placed on a rough plane inclined at 30 degrees above the horizontal. Given coefficient of friction to be equals to 0.2. So I'll be giving you a few minutes to look at this question, then we will proceed to the solution. Now, we have the horizontal ground, okay? And here is the plane inclined at an angle of 30 degrees to the horizontal ground. And we have the box of 2 kg, okay, resting on the plane that is inclined. So that means the weight we add downward. So the weight is what is given in the question, and that is as 20. Okay, so the weight is given in the question, and that's 20 Newton. So that means the mass of the box is 2 kg. Okay, so here we have the acceleration to gravity G to be what? 10 meters per second squared. Alright, so automatically for this mass to be on the plane, it will automatically slide down the plane, okay, at the angle 30 degrees. So meaning that the horizontal component of the weight is what is going to take it down. Meanwhile, the vertical component of the weight is still acting. So let's look at the components. So we have the vertical component of the what? Of the weight of the body, which is what? W sub y, and that will be equal to W cos theta. Now, the horizontal component, can you see resolving the weight into vertical and horizontal? The horizontal component will be W sub x, and that's what? W sine theta. Okay, now let's look at the normal reaction, okay, which is actually the vertical force that will be opposing, directly opposite the horizontal force acting on the body, perpendicular to the surface on which the body is resting. Okay, so that's the normal force. And now the next thing is that we are told that the body, okay, we are told to determine the magnitude of the minimum horizontal force that is required to maintain the box of a given weight 20 Newton from what? From sliding down. So that means the body is already moving down. Okay, now there will be, since the body is already moving down because of the what? Horizontal component of the weight, there will be a force that will oppose this weight. Okay, because it's the weight that will make it to move down. So there will be a force that will oppose it, and that force is what? The frictional force. So we need to maintain the body from sliding using what? So the force F sub x, F sub F, okay, frictional force, act this way since we are maintaining the body from going down the inclined plane by the horizontal force P. So here is the horizontal force P. Okay, now P can be resolved into horizontal component, okay, which is going to be parallel to the what? To the horizontal plane at an angle, that's P sub x at an angle 30 degrees, which is the same angle, okay, which is the same angle. You can watch my second video where I explain how to determine P sub x, okay, and P sub y, the vertical component of P. Okay, there I explain how we can use the relationship between these angles to determine the value of what P sub x will be and what P sub y will be. So we have seen how to resolve this. Now, from this interpretation, it will not be so easy to solve the problem going forward. Now, let's go. Now, recall from the law of solid friction that frictional force is proportional to normal reaction, okay? And that means the frictional force F sub F is equal to mu, which is actually the coefficient of friction, times the normal reaction. So, now, since the body is resting on the plane at a given point, summation of all horizontal components, okay, acting on the body, horizontal components of the forces, okay, acting on the body will be equal to summation of all vertical components of forces acting on the body of mass 2 kg. Okay, that is summation F sub x. Okay, summation F sub x will be equal to what? 0, and summation F sub y will be equal to what? 0. So record this. Now, after this, let's solve for all horizontal components of the forces. Now, since the summation of all horizontal components equals to 0, that means looking at this W sub x acting downward and F sub f acting upward. Meanwhile, we have P sub x also acting upward. Now, that means P sub x plus F sub f will be equals to what? Will be equals to W sub x. So that means W sub x equals to what? Equals to F sub f plus P sub x. Now, what does that mean? Since we know that what W sub x is W sin theta, and F sub f is what? Mu n. Okay. Yeah, and P sub x is what? P cos theta, like I explained. Okay, check my solution 2 in this playlist for more. I'll be putting it somewhere in this video, so just click on it to watch that video on how to calculate, how to determine P sub x and P sub y. Alright, so let's continue. Now, imputing the parameters that we are given. The weight is what? 20 newtons. So 20 times sine the angle, which is 30 degrees, will be equal to 0.2 times n plus P cos theta. Let's make that equation 1. Okay. Now, after this, let's look at the resultant of all vertical forces acting on the body. Now, so vertical forces are N, W sub y, and P sub y. Okay, so let's see what that is. Of course, N is acting upward. This is acting downward, and here is acting downward. So what does that mean? That means P sub y plus W sub y equals what? N. Right? So that N will be equals to P sin theta plus W cos theta. Okay? And we can put the parameters. So N equals to what? P sin 30 degrees plus 20 Newton. Okay? Or 20, just simply put 20 cos 30. That's equation 2. Okay? Now put N, okay, into 1. So we are going to replace this N here with the value that we have for N here. These two values. We're going to replace it. So what does that mean? Let's see what we have. So that means 2 sin 30 degrees will now be equal to 0.2 times the value that we have for N, P sin theta, P sin 30 degrees plus 20 cos 30 degrees. Okay, plus P cos 30. So now solving this, we have 10 equals to 0.1 P plus 3.464 plus 0.866 P. So we are solving for P. So collecting like terms, reducing to the lowest and collecting like terms, we have that P will be equals to 6.536 divided by 0.966, and that's going to give us 6.766 Newton, which is approximately 6.77 Newton, and that gives the minimum horizontal force required to maintain the box from sliding down the inclined plane. This is quite easily done. Okay, in case you have any more challenges, any more problems, feel free to reach out to me via the comment section, and subscribe and like my video. Thank you.